Today, I will show you how to solve the equation y double prime plus 16y equals u of t minus delta t minus 1 using the Laplace method. And you have these two initial value conditions go along with it. There are three steps you would take to, in general, solve this kind of equation. Step one would be to take the Laplace transformation of this equation. So each of these four parts, you will find the Laplace form of them, and then you plug them in. And so you will have a new equation with they'll have capital Y's here and there. Then you want to solve for the capital Y's. You want to move all of them to one side of the equation. And then everything else will be on the other side of it. And then the third step is inverse Laplace. Each of the parts of the new equation will capital Y equals everything. You would take the inverse Laplace of each of those parts and you get your solution. These will be lowercase y of s equals the entire solution. And if you have step functions stuff, you need to simplify something. So step one, we're going to go through and take the Laplace of each one of these four parts, starting with y double prime. To take the Laplace of this, we will use the form f double prime of t equals s squared capital F of s minus s f of 0 minus f prime of 0. We would use that, replace the f of y's, and we got our Laplace form for this one. Our next Laplace would be 16y. In order to find the Laplace for this, we can take out 16, so just be the Laplace of y, and the Laplace of y is just capital Y of s. Same with the, it could be, if it's f, it will be lowercase f equals capital F of s. And so what we have is 16 capital Y of s. Then we will need to, now we'll try and find the, since we have that, we'll find the Laplace of the third part, which is u of t, which is just 1 over s. That's just what it is, and vice versa. Now we'll find the Laplace of delta t minus 1, which we use the form delta t minus c equals e to the power of negative cs. Our c in this regard will be 1. So we'll just plug that in, and so our Laplace of the delta will be e to the power of negative s. And now that we have all four of the parts Laplace, we will plug them in, get the plug them into where they should go, get s squared capital Y of s minus s y of 0 minus y prime of 0 plus 16y of s capital Y of s equals 1 over s minus e to negative s, power of negative s. So that we took the Laplace. Now to start moving everything in one side, capital Y of s to one side, we will plug in our initial values, which will be y of 0 equals 0 and y prime of 0 equals 1. And since we have those here, here's y of 0 and y prime of 0, that will go 0, that will go 1. So now be this equation. Now we'll simplify this, how to move everything to the other side besides the y's. We will add the 1 to the other side, then factor out the y of s. So it'll be s squared plus 16 times y of s equals 1 over s minus e to the power of negative s plus 1. And then you divide by s squared plus 16, so it'll be capital Y of s equals 1 over s times 1 over s squared plus 16 minus e to the power of negative s times 1 over s squared plus 16 plus 1 over s squared plus 16. We did. We have capital Y of s on one side. Yay. Now we're done with step 2. Now we move on to the final step, which is step 3. We're 2/3 of the way through it. Now, each of these four parts, meaning this part, this part, this part, and this part, we will want to inverse Laplace it. So let's start with 1 over s times 1 over s squared plus 16. Now we can't just take the Laplace of this, so it's super hard to. It's practically not. It's not practical to do it. So what we'll do is we'll take partial fractions by combining the two fractions equals a over s plus bs over c over that. Then we will combine these two fractions and make the two numerators on each side of the equation equal each other. So be 1 equals a times s squared plus 4s squared plus bs plus cs. And then we factor that out, get that, organize it on both sides, plug in missing values for where we have zeros, and we get 0s squared plus 0s plus 1 equals as squared plus bs squared plus cs plus 4 squared a. And then we can put each of them, see how this is, these two are squares, it will equal this square, this is just s, this will equal this s, and number will equal each other. you put them in, put those equal each other, solve for the variables, you get a equals 1/16, b equals negative 1/16, c equals 0. Plug these back into this equation, and we get 1/16 times 1/s minus 1/16 times s over s squared plus 4s squared. That we can take the Laplace of. We can take the Laplace form of this, or those two things. So it would be 1/16, the Laplace inverse Laplace of 1/square s minus 1/16 inverse Laplace of s over s squared plus 4 squared. Now this, we have, these are both on the tables just as they are, with 1/s being u of t, like we did the inverse of Olio, or now we're doing the inverse of what we did Olio, and s over s squared plus a squared equals cosine at. So filling in the blanks of 4 being a and just that being ut, we get 1/16 ut minus 1/16 cosine 40. And that is our inverse Laplace of this part. Moving on to our next part, which is negative e to the power negative s times 1/s squared plus 16. Now we have in this form was an e to the power of a c, which is 1 times s times a function. And on our table, we have that. E to the power negative cs times a function. The inverse Laplace of that is u to subscript of c times t times the inverse of that function, t minus c, to t minus c. So let's do this. Let's first do the function, which is 1/s squared plus 16, which we can't take the inverse of that as it is. So what we do to make it doable is we will multiply and divide by 4. So it's equal. So we're not just putting something in there. So it works. So it equals 1. We're just multiplying by 1, which does nothing. So we can pull out the 1/4, so it's just the inverse of 4/s squared plus 4 squared. Hey, that we have that's on our table. The inverse of a/s squared plus a squared is sine of at. Hey, so we can just plug in a being 4, and we get 1/4 sine of 4t. Now, we can't just put that in. That's not just what we're going to plug in here, because it's f of t minus c. C being 1, we have to modify this part of it. So, and this part. So what it'll be is u to subscript 1, we don't show it because 1, times t minus 1 times 1/4 sine of 4, open parentheses, t minus 1, close parentheses, and that would be the inverse of this part. Now the third one is 1/s squared plus 16. We did that. So we know that the inverse of that is already 1/4 sine of 4t. So we already have that one done. And our last one is capital Y of S. We did that earlier. We're doing the inverse of it now. It's just lowercase s of Y of S. Plug all these parts in, and we get lowercase y of s equals 1/16 u of f minus 1/16 cosine 4t minus u, oh, not u of f, but u of t, sorry, minus ut minus 1 times 1/4 sine of 4t minus 1 plus 1/4 sine of 4t. Cool, we finished. That's the solution. But we should simplify some more because we have a step function here. So how we simplify this more is we do piecewise. Well, if t is greater than 0 but less than or equal to 1, this part practically goes to 0. So if this goes 0, then our equation is going to be a factor. I factor out the 1/16 here, make it easier, right? 1/16 times 1 minus cosine 4t plus 1/4 sine of 4t, because this is a step function. And here is this. And then this one we can just ignore. So because it's practically 0. So now if it's greater than 1, if t is greater than 1, then what we need to do is it will practically make this -1 not practical. It's just, we can get rid of it. So they will make this one negative 1/4 sine of 4t, which is the opposite of this one. So those two will cancel out. So it'll just be 1/16 times 1 minus cosine 4t. That will be if it's greater than 1. And that's how you solve this equation using Laplace.